My name is Nicolas Kral. I am the ConnectIQ Alpha Monkey at Garmin International, and welcome to Ware, Ware, ConnectIQ, and the Wearable World. So ConnectIQ, in case you're unfamiliar, which most of you probably are, is the app platform for Garmin products, Garmin wearables, and now Garmin bike computers. It allows third parties to create apps for our products. So the easiest way to explain what ConnectIQ is to say it's an app system like Android, but calling it Android is a bit too presumptuous, so I like to call it Roomba. It's like a much smaller robot, not a full Android. So usually the first question I get whenever I talk about ConnectIQ is why, and more specifically, why? In the past 2 years, there's been a number of app systems that have come out for wearables. There's Pebble, there's Apple Watch, there's Android Wear. So why not use an existing platform? Why create an entirely new one? So the goal with ConnectIQ was to bring third-party innovation to the Garmin products. What we wanted was to open up our devices to use cases we had never planned on. We wanted to take the essential pieces of the Garmin platform, which is location awareness, everyday wearability, and let people bring their ideas to it. But you have to understand that Garmin makes products with a purpose, because use case really does matter. For example, touchscreens are wonderful unless you swim, and then they are useless. Beautiful screens are wonderful unless you can't read them in sunlight, where a lot of people go running. So the use case of what we're designing the product for has a lot of influence on the products we make. It also helps to understand that Garmin customers are pretty intense. They expect their devices to survive marathons, ultramarathons, adventure races, Ironmans. They don't want to worry that halfway through the battery's going to die, or if the device is going to survive. They just expect that from a Garmin product. So for example, here is a sample recording that I grabbed off of Garmin Connect. This individual ran a 50K race. That's a 30-mile race. They ran it in 7 hours. They recorded their entire race using their Garmin. That's 7 hours of GPS recording, screen on, units going at full capacity. And I love this quote at the side. I felt great during my own race except for my legs. To which, you're running a 50K race, holy crap. So to do this, one of our biggest differentiators is battery life. You're not going to stop and charge in the middle of your all-day hike. So to meet our customers' needs, the ConnectIQ-enabled devices have way better battery life than most smartwatches. We measure battery life in weeks, not days or hours. So the Garmin Vivo Active, which I'm wearing right here, it gets, with BLE turned on, 3 weeks of battery life. So that is, you don't charge it every day. You don't even charge it every week. You charge it every week if you go running 2 or 3 or 4 times a week, or go swimming, or take it to the gym as I do. But it's orders of magnitude different than other devices out there. So to achieve this level of battery life, the devices have much less resources than other wearables or smart wearables on the market. We have wonderful battery life, but less code space or RAM than other smartwatches. For example, 32 megs of external DRAM, that draws a lot of power. So most of our products don't have that. Instead, we're using the RAM internal to the part itself. So for the Vivo Active has 256 kilobytes of total memory. That is as much RAM as as much space as the Apple Watch has for L2 cache. The Vivo Active runs at 48 megahertz. That is 10 times slower than the Apple Watch. Sorry. That's 10 times slower than the Apple Watch and 20 times slower than Android Wear. So we are working with the high end of low power embedded processors versus the low end of cell phone processors. So to review the challenges, we don't have one device. We have lots of devices that are aimed at different use cases. They can have different screen shapes. They can have touch screens. They can have buttons. They can have different sets of sensors. As we all know, developers love completely uncommon platforms. Totally love it. They love saying, oh yeah, I'm doing a port to everything. We have very little memory, and quite a bit of that memory is not allocated to the platform, but to the Garmin platform, your GPS and other sensor modules. We're running much slower. We're on the low end of the megahertz to milliamps. So that's great for the product, but developers are used to speed. We aren't necessarily guaranteed to have an MMU. I'm not sure if you have lived without one, but if you remember locking and unlocking of memory, if you programmed in the 90s, yeah, it's awesome. So in order to solve a lot of these power problems, we are working with a internally developed RTOS, internally known as Garmin Os. We have solved a number of the power problems that come with creating wearables, but we don't have, it's a monolithic operating system. It's not, it was never designed for loading third-party code. And we have never been a platform company. In fact, I will say that I thought creating the app platform, people would be impressed by creating an app platform. Instead, they were totally impressed that Garmin actually cared about developers. This was like this huge, that was what the story was Garmin actually is releasing things for developers. This is crazy. So we've never been a platform company before. This is new to us, and we didn't know if people would even be interested. So with that setup, how did we do Connect IQ? So when I came into the project in, I think it was May of 2013, I was more or less kind of told, make a Garmin API. That was about as much direction I was given. So the investigation started with what kind of development system, what kind of app system, what kind of development system would actually meet our needs. So I had many people tell me that it should have been a native system, and the challenge there would have been bringing all of the common operating system constructs to Garmin OS, and that seemed like a different challenge that was a bit out of scope. Java would have probably consumed too much of the product and not left enough for the product itself. And JavaScript requires V8 or JavaScript core to do a lot of optimizations of JavaScript code just so it can run in browsers, and you've got gigahertz there. So I was like, well, JavaScript is a great language. People are very familiar with it, but that's going to be too heavyweight. Python, Lua, Ruby, they were not designed for this low end of hardware. And then briefly looked at Arnold C, but which Matt Steele may be talking about later today, but may have been too risky. So what we needed was something that was simple. I mean, it had to be familiar to people, even if it wasn't something that was off the shelf. It had to be scalable. It had to run on this very low constraint, but we weren't going to stay low constraint forever. So it had to be something that could grow as time went on. And it had to be constrained but powerful, because so one of the challenges early on was that what was in the requirements for like the Vivo Active was 3 weeks of battery life. What was not in the requirements in the official document was an app system. So I couldn't just go around and say, okay, I get to redefine everything. In fact, that 3 weeks of battery life was very important. I had a lot of hardware engineers saying, you can't let them do things, like things. All things uses the battery that will, so we had to, in some way, protect users from developers from using all the resources of the device, but yet still enable developers to have access to the things that make our devices really cool. So what we needed was something that looked like JavaScript or Java or Ruby, but didn't use or have any language features that used memory or were inefficient. So we needed something that had less syntactic sugar and more syntactic splenda. So this is where Monkey C comes. At its heart, Monkey C was designed with the principle of least surprise. It derives from Java, Ruby, and JavaScript, but isn't quite like any of them. It's like if you know Spanish and go to Italy and you have enough knowledge to order gelato. It was designed to be easy to pick up for people who are familiar with web programming languages. It's a duck-typed language, but it's bytecode interpreted. So there's you write something that looks very much like JavaScript, but there's an in-between compiler that compiles it to bytecode, but yet it's still a dynamically typed language. So this was kind of a weird construct, but it's very much kind of like how Python compiles into to bytecode in between into the PYC files. It has a Java-esque object-oriented OO system, so it's single inheritance. But it uses also uses a reference counting system over a traditional GC for handling memory cleanup. The risk of a GC with low heap is that you're going to outrun the GC and fill up your heap well before it has a chance to clean up. Whereas a reference counter can clean up immediately after something's dead, but then you have the weaknesses of a reference counting system. One of the fun parts of ConnectIQ was that we had to define what a wearable app was, because this is early 2014, and we have our use cases, and we know that there's going to be other use cases. So what is a wearable app? And so what we came up with these 4 different app types. So the watch faces seem like a no-brainer. These run when the watch is idle. So these, the Garmin devices have a screen that is using a reflective technology, so the screen is always on. There's no, it lights up when you gesture, it's just on. So that means the watch face is always running. So this is where the hardware engineers were very concerned, because clearly I was going to enable destruction of our products. So what we did was the watch faces get updated, are told to update every minute, but if you gesture up, then we give them an event that says, okay, you can turn on timers now, you can animate. So this, I'll show you later some of the things that this enables. But we also give them access to some of the things running in the background, like activity tracking. So the watch faces can access the number of steps, what your step goal is, and then they can do whatever they want with that, which has enabled some really fun use cases. So data fields are plugins for the Garmin workout experience. This lets you write some sort of data field that displays alongside the Garmin running, like your distance, your pace. The easiest one to explain it would be beers earned. And we've tried to find, this one just conveys it so good. It's, you want to know how many beers you can drink after your run. So you take calories of your workout so far, divided by calories in beer, and display that as a number. It's very simple. But this is a metric we would never put into our products, but a third-party developer now is enabled to. It was like very early on that showed up. Widgets are, it's really hard to explain widgets without doing just a slight demonstration. So they are information that are available from the main watch loop. So here's my watch face, and I go over, here's my step count. Here is my 7-day history, swipe over. This is the sunrise and sunset. Here's the weather. So we allow developers to create widgets that fall into this loop, and they have access to the internet via a JSON request API, which makes a BLE request to the phone, to the Garmin Connect mobile app, which then makes the request to the cloud, and then serializes the data and sends it back over. So you can add in things that pull data for quick access. It's meant to. It's very much the equivalent of the Apple glances. I will say that when we heard them call it glances, we were like, we were looking for a word for that for like months. Glances. All right. So apps, the last use case, they have the most access to the Garmin system. And so an app, for example, can use the Garmin activity recording system to record workout data, you can start and stop a workout recording through the API. You have access to the internet requests, GPS, the whole as much as we can give you access to. So it's that's the app type that kind of enables the most powerful use cases. Oh, the other thing that I should talk about really quick is that the widgets and apps also have access to the Ant sensor system. So Ant, for those who are not familiar, I'll be talking about it a little bit later, is a low-power radio system for talking to different kinds of low-power devices. We use it for talking to our heart rate monitors and bike sensors and other things. And so with Connect IQ, not only do we give you access to talking to the sensors that we have support for, but we give you access to raw Ant so that you can actually talk to our Ant devices that don't exist yet. So another controversial aspect of Connect IQ is that we allow developers to target a device. So one device can cover very different markets and can have different inputs and different sensors. So the goal of Connect IQ is to allow developers to cross those boundaries. Like we're trying to make it very easy to make an app that goes across all our devices, but we very early on said it's not going to be write once, run anywhere, because that never works. It's going to be write once, port to wherever you want to. So for example, some of our devices have round screens. Maybe you like the round screens. Maybe you hate square screens. Fine. You have the power at the granularity level to say, I only want to support the round devices. F you, square devices. Maybe you like touch screens versus buttons. You are allowed to pick at the fundamental level, I want this app to be at these devices. Finally, we had to create a Connect IQ marketplace. It allows third-party developers to share creations with Garmin customers. Currently, the store is not monetized. So it was a place where you could, using our SDK, you could build an app, and then you could upload it to this marketplace, and then all users of that device of those devices could have it available for download. So to review, there's a whole new hardware platform, a new language, a new developer tools, and new app store. You can imagine there was a lot of confidence that this is totally going to work. So before we get to that, I'm going to tell you a little side story. When I started on this project in July of 2013, when I was really going down this path, my office mate and I named the project Monkey Brains, and specifically Monkey Brains, because it was me, and I really thought I was really not sure how far this was going to survive. So what the heck? It's Monkey Brains. So I asked the graphics team, which was at the time was just out the door, if they could draw up a logo, because if you have a logo, it's official. It's like, I've got a logo. It's totally happening. And that's what they came up with, which is Cornelius the monkey. At the time, he didn't have bubbles because we thought that was too much. And then at one point when we were sending a document out, somebody said that Garmin is a health and wellness company and we cannot promote smoking, so the bubbles came back. So we had multiple meetings trying to figure out what to call it, because we couldn't call it monkey brains. And there were meetings, but eventually we landed on Connect IQ. So fine. Officially, it's Connect IQ, but there's monkeys all over the place. The language name is Monkey C, because Monkey C, and then you start the simulator with Monkey Do, because of course. So it's the Monkey Brains plugin. It was monkeys everywhere. So in September of 2014, we're about to announce this at the Ant Symposium, and I was called into a meeting about the monkeys. So there was decisions about, how many monkeys are going to be? Is there no monkeys? So what we ended up with was that we got to keep the name Monkey C for the language, but it was no longer the Monkey Brains Eclipse plugin. It was the Connect IQ plugin. It was the it was the Connect IQ simulator. So everything 2 weeks before launch has to be reskinned. So during this process, I had been working 60-hour work weeks for months, and I was kind of almost about to lose it, just out of exhaustion. And my boss, who I have known for years and is wonderful, she recognized how much on the edge I was. And when I showed up at work, there's this stuffed monkey on a table next to my office, and he had a little banana bread and a little card. She had taken the time to reconstruct the Connect IQ monkey in physical form, and to this day, Cornelius the monkey kind of signified our over the we're making it to the finish line moment, and if you watch my Instagram feed, Cornelius the monkey ends up doing things and showing up in places. The two photos on the left come from Garmin fire drills, because we cannot leave our team member behind. So, to continue the story, where we are today is that Connect IQ, the store launched in January, and since then, over 1,000 apps have been uploaded to the Connect IQ store. We have almost 3 million app downloads since the store launched, and that's downloads and updates. 60% of our content is watch faces, because it's a watch, as it turns out, so people really but people really love personalizing their devices. They love that they can or have all these choices to choose from, and they can really make the device theirs. Last week we released Connect IQ 1.2, which is the second major update to the Connect IQ system, and it's been focused on trying to improve the app development tool so people can make more complicated and complex apps. So I'll talk for a second about good versus bad wearable apps. Wearable apps are really kind of in the Wild West right now. We don't even know what they're supposed to be. I think it's going to take a few years just for people to figure out what the right use cases are for wearable apps. Because we haven't, just like it took us time to figure out what a mobile app was when the SDKs first launched. Those paradigms had to evolve. So to us, good wearable apps are unobtrusive. You forget you're wearing them. You have limited interaction. We have tiny screens that you should not force the user to do a lot of stuff like this. save hard interactions for the web and phone, and the wearable app should have as little flow as possible. Keep it simple. Clean presentation of information. You don't have a lot of space, so use it wisely. Also, a lot of wearables, the more you use the CPU, the faster you burn the battery. So save your heavy computations that can be done in the cloud to the cloud. Bad wearable apps, they demand you focus on a tiny screen. You have to walk around like this, or this. They require you to do lots of swipes and button presses to accomplish limited tasks. They overwhelm the screen with too much information and have little key information in small areas. And they do too much on the wearable itself. So my photo is from a wearable that was a Kickstarter project, which actually it actually is an Android phone that they're wearing on their wrist. And I think that's kind of the wrong direction. They clearly thought it was, and I just love the quote from, I took this from a reviewer who, in the top line of the review, said, "I had to walk around with this on my wrist to write this review." Kind of almost blaming the writers for what pain he had to suffer, or the readers for what he had to suffer. All right, so here is a demonstration of a watch face that I really like. Our Taiwan team is great. So we have a team in Taiwan, and they have taken the SDK and they have provided a lot of Garmin branded watch faces. And this one is called Ninja. And when you gesture up, he does this little animation. Simple, right? They made another one called Playful Kitty that when you gesture up, there's this little cat at the border that kind of pops in and pops over and around. And you're just always, like, you check the time and you're like, aw. But the screen is always on, so it's not like you're ever blocked from seeing the time. It's not like you're waiting for it to light up. It's just that the animation just adds a nice little visual kick to it. The Steptress watch face is not made by us. It was made by a third-party developer. And it's a cute little watch face that uses the step count in an interesting way. So like I said, we've exposed your step goal and your current step count to the watch face. So when it starts out, there's a number of little Tetris blocks in the bottom third of the screen. And as you walk, those blocks start disappearing. So when you hit your goal for the day, you get the "you win" at the bottom. It's simple, but it sort of gamifies your activity tracking in a way that we just love that people are enabling. So for data field, I really like this one, even though it's not the most useful, but it's the nerdiest, and so I love it so much. So this is from the app description. Did you know that you might be literally younger if you take that run than if you don't? Einstein's theories of general and special relativity say so, and now you can have a data field that predicts how much measured in femtoseconds. A negative number means time for you has passed more slowly than time for a person standing where you started. You're aging slower. So yes, like I said, not useful, totally nerdy. Love it. But people can download and install that into their workout if they choose to. So this widget I thought was actually particularly genius. The Step Monkey widget combines activity tracking and a Tamagotchi. So it's on the widget loop, and your steps are turned into bananas that feed the monkey. So as you walk, first the monkey is in a gift box, and after a few days, he comes out of as a little baby monkey. And after a few days more, he goes into like an adolescent monkey, and finally in a full-grown adult monkey. So my friend Dave actually put it really well. It's a lot of fun to say, I have to step out and feed my monkey. So ant sensors are a really powerful area for Connect IQ. For example, the Moxie, a company in Minneapolis, has a muscle oxygen sensor. This is a sensor that can tell you how much oxygen is in your muscle, and if it can tell you that, oh, you've worked out past your crashing point, and help athletes find what that crashing point is. And so they can create the sensor, and then using Ant, use the wearable as the display. So it's cool the kinds of workout capabilities it allows. And we also allow, by enabling Ant, we allow Connect IQ to talk to other Garmin devices in really interesting ways. So I'm going to pull up. So my videos are not, I think I get one video. So I'm going to show you this one. So this is a demo that was created for the Ant conference. What he's doing is, these are Varia bike lights. These are bike lights that we create. And using the accelerometer on the Connect IQ device, it reads his gesture and is commanding the lights to do left, right, and stop. So this makes some technology just incredibly natural, but yet it makes it helps a rider at night be able to signal in a very natural way. I'm going to try one more time. I'm pretty sure this is going to fail. All right, so we're about out of time. I've got a wrap-up slide here. I am somebody who thought, like when I heard about the iPad, I thought it was never going to go anywhere. So take any predictions I give with a grain of salt. I do think that just like cell phones push processors for dual core, quad core, low power, I think wearables are going to push processors in a very low power, but high capability, very low power. I think things are going to be pushed in that direction. I do think developers will have to work on these platforms. It's not going to be as friendly as it has been. I mean, the Connect IQ, a lot of the 3 of the 4, or many of the wearables only provide 64K for your app. And that's kilobytes, and that's a word that scares a lot of developers nowadays, but it's a little old school. I do think that wearables enable kind of a now health. I like to think of wearable as it's the opposite of big data. It's micro data, wee data, small data. It's individual. But what they're really good at is being able to collect data from different kinds of sensors and tell you in a snapshot, this is how you're doing. This is what your heart rate is. This is what your step count is. And I think there's going to be more gamification, especially as more sensors come out that can measure different kinds of wellness data. I think there's going to be new ways of gamifying that for people so that they're encouraged to be healthier. So you can check out Connect IQ. We have our SDK for Mac and Windows at developer.garmin.com, along with the other developer programs. You can reach me at alpha.monkey@garmin.com. Yes, that actually works. And I am at Nick Creations on Instagram and Twitter. This is my personal account, not my Garmin account, though you may find more tweets about movies there than cool language things. But yes, thank you for your time. Lunch is going on right now, so I will be available for questions or go get some food.